Welcome back to Carneades.org. Today we're going to be looking at the number shortage paradox. So, 5 months ago, there was an xkcd comic entitled Number Shortage that took me down a rabbit hole. You can check out our recent X5 video for one branch of that rabbit hole, looking at the practical impacts of such a world. This is the other branch, looking at the philosophical questions raised. So, what was the comic? Number Shortage is a single-panel comic that portrays a mathematics department, quote, running out of numbers. The text of the comic says, the math department number shortage is getting worse. We have only 15 twos and 12 threes left. No wait, 13 twos and 10 threes. No wait. Basically, what is going on is that as the statement is spoken, the fast diminishing supply of numbers is reducing further. By saying we have 15 twos and 12 threes left, they use up 2 twos and 1 3. By making the statement, we seem to change the truth value of that statement. So, this raises a number of interesting questions. First, what is the truth value of the statement, we have only 15 twos and 12 threes left? By saying the statement, its truth value changes. At the beginning it was true, but by the end of the statement it is false, because we've used up some of those twos and threes. There are a few things that could be going on here, and we'll look at each in turn. So initially you might think that this is a paradox of self-reference, like the liar paradox. This statement is false. However, that doesn't seem to be what's actually going on here. We're not really referencing the statement itself. We're referencing things that make up the statement. Saying that Times New Roman is a font while writing in Times New Roman is not really self-referential, because it's not the statement referencing itself, just referencing the way that it's presented, which seems to be something like what we're doing here. Further, it doesn't seem to pose the same issues to be just referencing part of a statement as it does to reference the entire statement. In fact, most statements seem to do that. If I say the word tantamount has 10 letters, I am referencing a component of the statement, a specific word in the statement, namely the word tantamount. But we wouldn't call that self-reference because it's not referencing the whole statement in the same way this statement is false is doing. Because it doesn't reference the whole statement. And it seems most statements are somewhat self-referential. If you're using a pronoun to a certain degree, you're referencing another word or another referent within the statement. So one way to see this might be to make our statement a bit less abstract. Perhaps instead of running out of numbers, we could imagine a household where the parents only allow their children to say the word shit 5 times a day. If one child says, we've used up 3 of our shits for the day, it seems that they're not actually referring to anything within the statement, but rather the 3 other times during the day that they used the word shit. The problem is that by saying this statement, they have used the word a 4th time. In doing so, they're not referring to the whole statement, just one of the words in it, as with the statement about the word tantamount. The problem is that this makes the statement true when it was started, but false by the time it ends, in a similar way to our original paradox. Now, perhaps then what is going on is we're talking about illocution. We're doing something with words, using up the numbers. So maybe we have some illocutionary force that's separate from the statement's locution, to use the language of utterances from the works of J.L. Austin. Check out our videos on locution and illocution for more on that. However, this doesn't seem to fit exactly either, as illocution is about the intent of the speaker, such as when you say, that tree is about to fall, you're not just stating a fact about the world, the locution, but you're telling someone to get out of the way, the illocution. Nor is it really the perlocution. It isn't the impact on the listener either. It's in some way the impact on the world. Is not the speaker's intent to use up the numbers. It is just a feature of the statement. In some way, it is the phatic act, or perhaps the phonetic one, to use Austin's term, that does the work here. Once we succeed in referring to the numbers or speaking them, the action is taken, depending on exactly how we're capturing when the numbers are used up. Now, another possibility would be that these are self-affirming or self-defeating statements, statements which make themselves true by their utterance. Note that these are distinct from tautologies, which are a priori logical truths, but rather statements that depend on their utterance for their truth value, i.e., they are not about their own content, they are about the way they are being expressed. So common examples of this include I am speaking, which is self-affirming, at least when it is spoken. A claim that you make true by stating it. These are often confused with logical tautologies, which are true regardless of whether they're stated. They are logical truths. I am speaking is not a logical truth. It's not always true. But rather, when I say the statement, I am speaking, I must be speaking. On the opposite side of that, we have self-defeating statements like I am silent, because you make it false by saying it. Once again, these are distinct from logical contradictions, which are inherently contradictory, as opposed to being contradictory only when you're saying them, or false only when you're making them as a statement. Now, these seem closer to what we're getting at, but they're not quite there, because it's something about the utterance that's impacting the truth value. The truth of the statement, we have 15 twos and 12 threes left, seems to be in some way impacted by it being said. But unlike I am silent, which is false as soon as you start speaking, or I am speaking, which is true as soon as you start speaking it, it seems like the truth value of we have 15 twos and 12 threes left changes partway through the statement. When we say 15, that number is correct. It's an accurate depiction of the number of twos that we have. But once we've said twos, it becomes false since we've used up another two and we're down to 14. So while it was true at the beginning of the statement, it is false by the end inherently. Now, this may not be a paradox. It seems like there are other statements that can change truth value as we say them. I can say, I am running, in such a way that when I start the statement, I am at a standstill, but when I complete it, I am actually running. However, this seems importantly different from our statement about numbers, which inherently changes its truth value, instead of merely conditionally changing its truth value based on the state of the world. Even so, perhaps then the issue is one of temporal ambiguity. The statement, we have only 15 twos and 12 threes left, is temporally ambiguous between two options. We had only 15 twos and 12 threes left when I started speaking, and we will have only 15 twos and 12 threes left when I am finished speaking. Depending on which one of those you mean, you can assess the truth value of the statement. By clarifying the time that we are indicating to check the truth value of the statement either before or after the speaker is done, the paradox seems resolved. The first statement is true, while the second statement is false. We need a point in time to assess the truth value of the statement. Once we have that, problem solved. However, this will run into its own problems. If we look at just one more line into the comic, the speaker next says, no wait, 13 twos and 10 threes. Looking at this previous statement, we have only 15 twos and 12 threes left. We see that two of the twos were used up in that statement, as was one of the threes. But then, where did the other three go? We went from 12 to 10, so we used up two. We've only used up three in the previous statement. Well, it was used up halfway through the second statement when we said 13 twos. It's important to note that this is not how we treat statements in the X5 video because it leads to this exact paradox that we're talking about here. We assess the truth value of all the pieces of the statement at the beginning and then just state them because it can lead to a bunch of changes. However, if you're choosing to assess at each point and actually try to say the number of things that you have at that moment, which seems to be what the comic is doing, we run into this new paradox. So let's take a look at exactly why this is a problem. So the issue here is that the statement seems to be true at any given point in the statement, but is never true entirely. At the beginning, there are 13 twos and 11 threes. In the middle, there are 12 twos and 10 threes, and at the end, there are 12 twos and 9 threes. The statement seems accurate as a whole, because at every point we were correct in saying, when we said no wait, we got to the 13, we had exactly 13 twos, and then when we got to the 10 threes, we had exactly 10 threes. However, it was never true that we had 13 twos and 10 threes. Now, you might say that, oh, there was a moment between saying 13 and saying twos where it's briefly accurate, but we can get around this. You only need to add another digit to make this not the case. We have 2 ones, 3 twos, and 10 threes. Let's take a look at that statement. So if we said we have 2 ones, 3 twos, and 10 threes, this statement has the issue that it is true at every individual moment. It is true at every point we are saying it, but at no point is it fully true. We never actually have 2 ones, 3 twos, and 10 threes. So let's take a look. To start off, we have 2 ones, 4 twos, and 11 threes. We then use up 1 2, so we have 2 ones, 3 twos, and 11 threes. But when we're assessing this 2 ones, we were correct. We do have 2 ones when we started saying 2 ones. but then we use up one of the ones. So we now have 1 1, 3 2s, and 11 3s. And so when we get to the part of the statement that's about 2s, we look at the number of 2s we have, and we do in fact have 3 2s. So we then have 1 1, 3 2s, and 10 3s. This is the first point in the statement where the number of 3s that we're going to say actually corresponds to the number of 3s that we have. But you'll note at this point, we already have gotten rid of one of our 1s. We only have 1 1 left, and we're not going to get another 1 by the end of the statement. And so any point after this in the statement is going to be false because we've already used up one of our 1s, and we said we have 2 1s. From that point on, we have 1 1, 2 2s, and 10 3s. So the 3s part of the statement is correct, and the 2s and the 1s part are wrong. Then we have 0 1s, 2 2s, and 10 3s. And finally, 0 1s, 2 2s, and 9 3s. So at no point in this statement is it fully correct, and yet at every point, the truth value of the next set of words are correct. So one might try to resolve this by adding the use of the word now throughout the statement in a few places, in the same way that the statement I am running now, but I am walking now can be true because the nows are picking at different points in times. For example, we have 2 1s now, 3 2s now, and 10 3s now, capturing 3 different points in time. However, this is not actually correct, as by the time we get to the first now, we actually only have 1 1 left. Yet when we started saying 2 1s, it was accurate. You could try to go down this rabbit hole further. We can continue down this rabbit hole, looking at exactly where in the sentence we're assessing its truth value and where we are determining what to say. But this raises more questions. Are we assessing truth value between the 1s and the 10s digit if the 10s digit changes number? I.e., if we have 13 1s, should we say we have 13 1s, even though by the time we're past the 10s digit, we actually have 12 1s because we used up 1 1 in that first half? And if we should say that, if we should say we have 12 1s, what about if we have 10 1s? Once we make it past the 10s digit, we only have 9, but we can't go back and change the 10s digit now. And if we don't go back and change the 10s digit, then the truth of our statements is actually dependent on what base we're functioning in, which seems like a ridiculous conclusion to arrive at. Now, whether or not you think this is a real antinomious paradox or just something falsitical, statements like this, which inherently change their own truth value, seem spooky at best. There seem to be a lot of questions around when their truth value should be assessed and how they are impacting their own truth value. What do you think? Is this a case of a real paradox or just the case of a weird type of statement? If you're interested in a more practical approach to these questions, please do go check out our video, The Great Number Shortage, over on our other channel, X5. Watch this video and more here at Carneades.org, and stay skeptical, everybody.